Hello everybody and welcome back to Arduino for Amateurs. This is episode 9, Neopixel Ring. As always, my name is Matt Gracie. I'm a hacker from Buffalo, New York. I'm a member of the BitHaven Hackerspace. And what I'm going to be talking about today is Neopixel rings. And what, you might ask, is a Neopixel ring? Well, let's contrast it with the LEDs we looked at in the last video. So you may remember this photo. This is a traditional regular blue LED on the left. As you can see, it's got two prongs, two legs, and then an RGB LED on the right. And the RGB LED has 4 legs, one each for red, green, and blue, and then one ground, right? So if you remember from our last video, the way we set the color on an RGB LED is we use those PWM outputs from our Arduino, the pulse width modulation outputs, to set values for red, green, and blue. We push that voltage into the RGB LED along those 3 wires, and then the ground goes back to ground on our Arduino. And that allows us to set a particular color for particular values of red, green, and blue. And in the last video, we actually hooked one of these to potentiometers, remember, so we could set the relative levels using physical knobs, using red, green, and blue knobs. A Neopixel ring, or a Neopixel device in general, is a little bit different than that. So let me show you what I'm talking about. I went on Amazon, as I do, and I just did a search for Arduino, looking for neat little hardware bits, as I do. And this is one of the things that came back. So this is a collection of 5 Neopixel LED rings. These ones are 16 LEDs apiece. You can see over here they're available in a variety of configurations. So you can get, this one's got, 7 or 8 LEDs. This one's got 12. This one's got 16. This one's got 24. So you can get these in a variety of sizes. And the cool thing is they are WS2812 compliant. So what does that mean? That means that each of these little white boxes here is a combination LED and controller chip, a controller circuit. Each one of these is individually addressable. So I can set each of these to a different color, or I can turn them on, I can turn them off, I can make them strobe, I can do anything I can programmatically come up with, I can make these rings display. It's pretty cool. If you look around online, there's some neat cosplay where people have used these for like goggles or for like prop, space ray guns and that kind of thing. But the principle, whether we're talking about rings like this or we're talking about strict strings of lights, is the same, right? We've got a bunch of individually addressable LEDs that we can set to all one color or we can set to individual colors. Now, the cool thing about WS2812 is, for one thing, it runs on 5 volts of power, so we can light these up directly off the Arduino. We don't need any kind of external power supply. And another thing is, again, each of these are individually addressable. If you look at some other devices that may say WS2811, those are slightly different. 2811s run on 12 volt power instead of 5 volt power. Overall, they require a little bit less power because they also do not have integrated circuits in each lamp. The way they're designed is there is one control circuit, one control chip per 3 LEDs instead of 1 in each LED. So if you have 60 LEDs, you can set them to 20 different colors. You address them in groups of 3 as opposed to addressing them individually like you do here. So overall, the Neopixels, the WS2812s, require slightly more power because they're powering more components, but they give you finer grained control. So if you see Christmas lights or light strips or rings like these or any other electronics that say WS2812, that's what we're going to be playing with today. All right. So I ordered these. I spent the princely sum of $18.99 to have 5 of them delivered to my house. And what do they actually look like? Well, here's two of them on my desk. They're about, I don't know, 1.5 inches across. On one side, you have all the LEDs, and again, we have 16 of these individually addressable LEDs. And on the back, we have 6 through holes, which are labeled here. So we have 2 of them that are labeled G and D. Those are obviously our ground. We have 2 of them that are labeled power 5 volts. Obviously, those are our power in. And then these 2 are labeled DO and DI. And what those stand for is data in and data out. Now, why would we have a data out through hole on these rings? Theoretically, and I have not gotten this to work myself, if anybody has any pointers, feel free to leave them in the comments. Theoretically, we can daisy chain these together. So we can hook our Arduino to data in, and then data out we can run to another ring on data in, and then data out from that we can run to another ring on data in, and so on. Sort of chain them together, and then treat them all as just one very long single entity programmatically. So one of our rings has 16 LEDs on it, so we address them as 0 through 15. Being good computer scientists, we start counting at 0. If we add a second ring, that should be numbers 16 through 31. Adding another ring should be 32 through 47, and so on, right? So we should be able to chain them all together and make them work. I haven't been able to get that to work properly. I'm sure it's user error. I'm just doing something wrong. But if anyone has any troubleshooting tips, I would appreciate it. Now, how are we going to wire these up to test them and make sure we know what we're doing? Well, this is the circuit that I built. It's very simple. We've got power, which is hooked to one of those 5 volt in through holes on the ring. We've got ground, which is hooked to one of the ground ones. And then our data in is this yellow wire, is hooked back to pin number 4 on our Arduino, right? As you can see, power is coming off of the power bus here. Ground is coming off of the ground bus here. And then I've got power and ground on my Arduino plugged into the bus. So that's what the circuit is, right? The power comes out of here, goes into the power bus. The power bus is connected to power in on the ring. Ground is connected back to the ground bus, connected to the ground bus here, connected back to the ground pin on my Arduino. Very, very simple. This white wire isn't doing anything electrical. It's just holding the Arduino in place on the breadboard. It's strictly cosmetic, so it doesn't fall apart when I pick it up. And then again, this yellow wire going from pin 4 into data in on our ring. That is the only thing that we need to connect. So in contrast with the RGB LEDs, remember for the RGB LEDs, we had a red wire and a green wire and a blue wire, and we had to send separate signals on each one. For these Neopixel rings, it's a single wire that's controlling it. And it's not even just controlling one LED, it's one wire that is controlling the color of every LED in the ring, which is pretty cool, right? Makes it much, much simpler to wire this stuff up. In a real hardware project, if I was deploying this for a costume or some sort of real purpose, I would probably use these through holes on the ring to solder wire in and get everything connected up more permanently. But in this case, since I'm just kind of playing around, I just stuck everything into a breadboard. Should be good enough to demonstrate what we're doing. All right, so let's take a look at the software now that we've got the hardware part of this figured out. I just started a new sketch here. And if I want to do anything with this Neopixel stuff, the first thing I'm going to need to do is load the appropriate library for it. A library is like a hardware driver, right, for an Arduino sketch. It gives us the programmatic hooks and the programmatic functions that we need to interact with new hardware that's not part of the core Arduino platform. So to get to our libraries, we can either go to Tools and then Manage Libraries, or we can click on the little library icon here, the one that looks like a set of books. So we click on that. We put Neopixel in the search box here. I obviously already typed it in. And we get a list of all the Neopixel libraries here along the left-hand side. The one that we want is the simple Adafruit Neopixel library. So we'll hit install. It will process it. It will install the library. And here we go. Output, downloading, installing, installed. So, and this has changed from install to remove. So if we decide we don't need this anymore and we really need to reclaim that, 37 kilobytes of space or whatever it is on our hard drive, we can do that. Now that we have installed the library, we can take advantage of it. So let's go back to our new sketch here. And the first thing I'm going to do is use pound include and the name of the library, Adafruit Neopixel.h, and that will include the library for me. So now when Arduino compiles this, it will pull in the headers, that's the .h, from this Adafruit Neopixel library, and it will allow me to use the appropriate functions. Okay, so I'm going to define a couple of constants here, just to make the rest of my code clearer. I'll define pin, and pin will be the number 4, right? Pin is just going to be the number of the pin on my Arduino that I've plugged this stuff into. And then we'll define number of pixels as 16. So we've defined two constants here. One is the number of the pin that I'm plugging into my Arduino, that I'm plugging between my Neopixel ring and my Arduino. And one is the number of pixels that are in my ring. If I had one of those larger rings with 24, it would be 24. If I had one of the smaller ones, it would be a smaller number. If I was chaining two of them together, like I discussed earlier with the data in and data out ports, it would be 32. And then I just treat it all as one big entity. In this case, we're starting with just one ring, 16 pixels on it, so we'll say 16. Okay. Now, I've included the library. I've defined my defined my constants. So let me initialize an Adafruit Neopixel object here. So Adafruit Neopixel. We'll name it pixels. And then we'll use our constants. So we'll instantiate it with number of pixels, pin, and then these variables you don't really need to know. Those are related to how the data is encoded going to the Neopixel ring. So we're encoding green, red, blue, and 800 cycles, basically. So that's the encoding standard that's going along that single yellow wire between my Arduino and my Neopixel ring. So what we've done is we've instantiated an object named pixels that's got 16 pixels connected to pin 4 and is encoding data using those particular items. And we're ready to get started with our setup. So let's get rid of that example there. We'll say pixels.begin. That will create our object, provision it in memory, get it ready to go. We'll say pixels.set brightness. We'll set it to 20% brightness because I'm not in an especially well-lit room and I don't want to burn my eyes. We'll say pixels.clear, which will clear out the registers, like the cache that contains data about the pixels. And we'll say pixels.show. And what that will do is it'll basically turn on the pixels. We've just cleared them, so there's no value in there, but we're sort of just doing our setup like the function says, right? We create the object, we set the brightness on it, we set them all to no value, don't show any colors, and then we turn them on. So this is our setup, and when this is done running, basically nothing should happen, right? We're creating the pixels object in memory, but we're not doing anything with it yet. Then in our loop, what we're going to do is we're going to use a for loop, And basically the 16 pixels in this thing are treated like a 16 unit array, a list of 16 values. And we're going to use a for loop to fill that up. So we'll say for int I equals 0, I is less than number of pixels, I plus plus. And what this is doing is, if you don't recall the last time we used a for loop, we're setting up a counter variable. That's this variable I for integer. That's the name of our counter. Integer will be set to 0. And then every time we come back to the top of this loop, it's going to run this comparison here. It's going to say, is I less than num pixels? So is I less than 16? If it is, add 1 to I, that's the I++, and run the contents of the loop again. Once I is equal to 16, it is no longer less than 16, then the loop will exit. Okay? And what we're going to do is we're going to say pixels set, lowercase, set pixel color I pixels dot color 150.0.0. Okay, we got a double parenthesis there. Pixels dot show. Right. And we can just leave it at that for now. So what is this doing? We're going through with the for loop and we're saying for int I equals 0, I less than num pixels, I++. So we're going to run this loop 16 times. I equals 0, I equals 1, I equals 2, I equals 3, etc. And each time through, what it's going to do is it's going to set the pixel color for I. So first LED 0, then LED 1, then LED 2, etc., all the way around the ring, because these are all individually addressable. It's going to set it to the color 150, 0, red, green, blue. So it's going to set it to red. It's going to set all the LEDs to the same color. Not because it has to, not because I can only set one color, but because we're just doing something simple right now to make sure that everything is wired up and everything works the way that it's supposed to, right? So it's going to set all of those pixels to red. It's going to do pixels.show, meaning now that I've set the values, turn the LEDs on, right? Basically refresh the state of the LED with the color that I have set. And then that's the end of the loop. So this is a super, super simple program. All it should do is light up our ring here, which you can see right here. It should just light up our ring and turn it red. So let me do my check here. Make sure I didn't miss any semicolons or anything. Nope, says everything looks good. Okay, so I will plug in my USB stick. I will hit upload. And there we go. Our ring lit up red. So it works the way that we expect it to work, right? We are able to programmatically set the color of those ring pixels using this for loop. We set 0, then 1, then 2, then 3, then 4, etc., up to 15 to 0, and then we did pixels.show to light them up and show the color that we've put in there. So our code works, our library works, our wiring works, everything is functioning the way that we expect it to. So this is a very good sign, right? It means we're in good shape, and now we can start doing some more interesting stuff with this. We can interface it with buttons or potentiometers or change colors. We can set the LEDs to different colors. We can create patterns. We do all kinds of cool stuff. And that is what we will start doing in the next video. Thanks.